today's class is regarding Z-score, its application and uses. Okay. Let us take the population. Then what is population? Population may be the maybe the association of the data. Association of the data we collected from the
for the research purpose.
For the research purpose. That is maybe the population. Population may be very large.
Yeah.
Population may be very large. And if the population is very large, okay, we can get a distribution that is called normal distribution.
Yeah.
Why it is so called? Why is it so called normal distribution? Because most of the data are concentrated, are accumulated at the middle of the middle area
of the distribution.
That is why it is called normal distribution. Now, normal distribution maybe another name is Gaussian distribution. As Gaussian has invented this type of distribution. Okay, it is an empirical distribution, we can say. Because empirical in the sense that we have to collect the data from the population.
Yeah, it's raw data we collected for the research.
For the research purpose. Okay, so this is the normal distribution curve. We can get a normal distribution curve, bell shaped. Okay, it is here. It is 50%, and on the side it is 50%. Data are concentrated. Fine. Now, in the middle, we can see mu is the middle. Mu means mean. The mean of the data is at the middle, and on the right hand side, it is 1 SD plus 2 SD, then 2 SD, then 3 SD on the right hand side, and the left hand side, it is minus 1 SD, minus 2 SD, and minus 3 SD. SD means standard deviation. Okay, so this is the characteristics of normal distribution. And we can see that empirically we have seen that the
38%,
68.8% of the data are concentrated in between minus 1 SD to plus 1 SD, and plus 2 SD to minus 2 SD there are
95% data concentrated in between
plus 2 SD and minus 2 SD. And here on 3 SD plus 2 minus 3 SD,
in between 3 SD
plus minus 3 SD, there may have 99% data.
Of the data.
Okay. Now, the thing we have not at all touched about Z-score. It is nothing but your normal distribution. It is nothing but your
normal distribution.
There is huge difficulty in using this type of normal distribution. Because of that, there is a leap from 1 SD to 2 SD and 2 SD to 3 SD minus. On plus side, it is also there like that. Basic question is, if some data, if you want to identify some data in between this 1 SD and 2 SD, or in between 2 SD to 3 SD, this distribution table becomes helpless. Becomes helpless. It cannot
determine
that because of that normal distribution empirically plus 2 SD and minus 2 SD, and there is an approximation of that. Okay. Now, normal distribution, if it has some type of difficulties, fine. We should devise some another method that is called standard normal distribution. That is called standard normal. So from normal distribution, you have to convert it to standard normal distribution. You have to convert it to standard normal distribution. So why should we convert this? Because of what I have already told you, that if the data are we need to get a data in between these 2 SD. If it is purely 1 SD to 1 SD, you get 68.8%. But if we can get 1.4 SD minus 1.4 SD, if we want to get some data, it is helpless. It cannot give you the result. That is why
overcome that kind of problem.
To overcome this type of problem, or to overcome this problem, we convert this normal distribution to standard normal distribution. Then what are the features of standard normal distribution? What is the property of standard normal distribution? What does it tell? It tells you that mean is 0. So standard normal distribution, it is also taken as a bell-shaped curve. It is mean is 0. Right, on the right side it is 1. So the basic features what I have told you is that bolo, mean is 0 and here it is 1 and 2. It is -1, -2, -3, like that. Fine. To put whole the data, to put whole the data to standard normal distribution, you use a formula. That is very, yes, you have to take this data from normal distribution to the
standard normal distribution.
You have to use a formula.
We have to use a formula that is quite common, and we also use it in case of t-test and z-test.
That is x minus mu by st. The x minus mu by st.
X minus mu by st. X minus mu by st.
Okay. If we can get some data for empirical analysis, suppose there are five observations are there. 1, 2, 3, 4, 5. Then what is the mean? Mean is 3. If we can, as it is serially distributed, we can say that we can eliminate the outer and the middle is 3. 3 is the mean. Or you can get that you can just add it up and divide by 5. You can get 3. 15 by 3. Fine. And from 3 to 1, from 1 to 2, 2 to 3, 3 to 4, 4 to 5, standard deviation is 1. Now, if we can put this figure in the formula, x minus mu by sd.
Suppose
suppose if we can get the middle figure, as it is middle, it is the middle of the bell. So here it is 3, and 3 minus 3, mu is 3 also. 3 minus 3, sd is 1. It is 0. That is why the basic features of this standard normal distribution, mean is 0. Fine. Okay. And it is plus 1 sd, plus 2 sd, minus 1 sd, minus 2 sd. And sd is 1. So we need not write here sd. Always. So for standard normal distribution, always there are mean is 0. We convert the data in that way by using this formula that mean is 0 and standard deviation is 1.
Yeah.
Very fine. So it's a continuous distribution.
Obviously.
Fine. If we want to find out 1 sd, 2 sd, we can use normal distribution. But what for 1.5 sd? We use SND.
Same formula.
We use
SND. Standard normal distribution.
Fine. And to find a particular value in the SND, we need a Z-score. We need Z-score from Z-score table. Fine. Let us take an example. Suppose there is a class, and the marks obtained in that class, we got a mean of 75, and standard deviation is 10. And standard deviation is 10. And now, if we want to get a value, what is the value? Value of probability. What is the probability that a student may get more than 60?
In that particular class.
In that particular class. Fine. It is more than 60. So from normal distribution, if we can plot it to the normal distribution, it is the bell-shaped curve of the normal distribution, and the mean is 75. Mu is 75. Fine. Standard deviation is 10. So 75 plus 10 is equal to 85, and plus 10 is equal to 95. Here it is 65, and here it is 55. Now if we want to get the probability of getting 65 marks, we can use the empirical method of that very percentage year to year. Paka. But our objective is to find out 60. 60 lies in between 55 and 65. Suppose here it is 60. Fine. Normal distribution becomes
here normal,
yes, it fails to do.
Exactly.
It fails to give a particular result. Now we have to convert this data to
standard. Now here's a use of standard normal
that
distribution.
data is plotted now to a standard normal distribution. But okay, and as per the property of the SND, standard mu is 0. Here it is plus 1 SD, that is plus 1, plus 1,
Plus
plus 3, plus 2, plus 3, minus 1, minus 2, minus 3. Fine. Now on the right hand side of the bell shape curve, here it is 50% data, and on the left hand side it is also 50%. Now Z is equal to, here it is 1.5. Suppose here it is minus 1.5, minus 2, here it is minus 2, means 55, minus 1 means 65. So 60 lies in between. Here it is only minus 1.5, minus 1.5. Here's the significance of Z-score. Okay, now you go to another table, another page. You can find the Z-score value of minus 1. Z-score value of minus 1.5. Fine. From the table we have got that it is 0.0668. How we have got it? You have to explore the Z-score table. Fine. So here it is Z-score table. We got 0.0668. It is approximation. In terms of percentage, it is 6.68%. It is in percentage terms. It is
6.68%.
now the matter become very simple, and simpler than simple in the sense that the left side portion is 50. Now here it is 1.5. So if we can segregate three parts,
It's just our assumption that here it is 1.5.
here it is 1.5 minus 1.
Yeah.
Here it is minus
2.
2.
Okay.
So it is empirically 65.
Yeah.
It is empirically 55. So 60 lies in between these two, and then in between these two 60 plus 5 minus 5. So 60 must be minus 1.5. That is not at all assumption. Fine.
Okay.
It is minus 1.5. It may be minus 1.4, minus 1.2, whatever may be the value, depending on the on our estimation, on our prediction parameter. Fine. Now Z-score minus 1.5 is nothing but point. In terms of percentage, 6.68. Here it is 50% total. Here it is that portion. Third portion is 6.68%. So this portion is 50 minus 6.68%. It is 43.32. Fine. Here it is 50. 50 plus 43.32. 50 plus
43.32.
is nothing but total kitna aaya bolo. What is there? 93.32%. Okay, so the answer is that the probability that a student may get more than 60% is 93.32%. Okay, 93.32%. And it is, you can say it very empirically also. You can say it very empirically also. Z-score value is 1. The Z-score value of minus 1.5 is what is Bolo? What is it? Is
0.0668.
It is in terms of percentage 6.68. So 50 minus 0.68. It is 43.32, and 43.32 plus 50 is 93. Now empirically, out of your own sense, you can make it tally. Because of that, the mean is
75.
75. On an average, students are getting 75% marks, right? A standard deviation is 10. We want to get a percentage 60. It must be a higher percentage. We have taken the 60. Suppose it is maybe 90. The percentage must be lower. Pakka na? So it is 93.32 is the answer empirically, and it is the use of Z-score. It is the use of conversion from normal distribution to standard distribution. It's okay. Now over for the time.